Hello and welcome to Containers 214, Fidelity Investments, 2 years and 10,000 containers later. My name is Ike Arias and I'm with the Container Services team here at AWS. And it's a pleasure for me to introduce Niraj Amin and Rajarajan Pudapati. They're from Fidelity and they're joining us today to present a shared services platform that they've been building for many years now. They've presented in the past at reInvent, and today they're offering some new insights and discoveries. Welcome, guys.
Yeah, thanks, Ike, and thanks for having us. So as Ike mentioned, my name is Niraj Amin. I'm a cloud platform architect at Fidelity. My primarily focus and passion really is cloud platforms, and intuitively that means Kubernetes and EKS. As Ike mentioned, about 2 years ago, Fidelity Investments had a reInvent session that was really elaborating on our vision and really to talk about our next gen cloud platform that we were working on. So this is really a follow up to that session. Talk about various things that I'll get to here in a second. So the agenda for this, as a segue, is really to talk about our platform goals in general, and really why even have a strategy in the first place. Go a little bit into detail about the platform architecture, and then I'll be turning it over to my colleague Rajan to talk about the platform building blocks, how we've kind of driven adoption, and the lessons learned along the way. Selfish plug, Fidelity Investments. Hopefully you guys have all heard about it, but it's a 70-year plus company now, primarily focused on the financial space, 401ks, investments, etc. It's a large enterprise company. It's 50,000 plus employees. We have about 15,000 plus technologists. And really, Fidelity sees itself as a technology-first company. We've, as you can see from the slide, in 1965 purchased our first computer and started leveraging technology then. But really, more importantly, in the last couple of years, Fidelity's taken a posture of really going into big data, mobile, and more recently, cloud strategies. So when we first started about 2 years ago, we really wanted to focus on the why of the platform. So there's really 5 or 6 things that we thought were important. First and foremost is the scalability and agility of the platform. So we have today upwards of 175 to 200 clusters. And we haven't grown that fast, just without having that proper plan in place. So the biggest thing for us was to make sure that we can scale, especially at the enterprise level. We have tons of business units, tons of developers, tons of different DevOps teams that use the platform. So we wanted to make sure that when we went from cluster 1 to cluster 175, we had a mechanism in place to get us there. The second most important thing for us is innovation. In today's world, technologies change quickly. There's new tools, new fundamental practices that come in place. So we wanted to make sure that the platform was agile enough and innovative enough to pick up something that we felt was a business difference maker or a technology difference maker that we can quickly get in and really enable for our clients. Being in a financial space, reliability is also key. We can't incur outages. We deal with people's money. So it was important for us to make sure that the platform was really highly available and could scale across multiple availability zones, regions, etc. The other key for us is really around cost. We wanted to make sure that the users of the platform could really gauge how much their particular applications were costing them, right? Whether that be in the Kubernetes world around metrics around deployments or pods or even higher level in terms of namespaces. So that was a key for us as well. And finally, I think we've probably all been part of technologies or where things are more of a black box. So we really wanted to avoid that here. We, as you'll hear later on in the presentation, we do add in a bunch of enhancements and manage certain life cycles of different things on behalf of the client or on behalf of the developers. So we wanted to make sure all of those things were fully transparent. And when we kind of go through the platforms and a developer wants to figure out why a certain component's not working, or if certain component is doing something else, they have full access to all of their particular logs, assets, etc. as well. So question always comes up, why even have a strategy in the first place, right? I think I kind of touched upon this, but we really wanted to make sure that we could scale. That was our biggest thing. It's okay to, for various reasons, do things as one-offs, but we knew that we were going to grow with the size of how large Fidelity is. So we knew that we had to scale. That was key, and that was important for us. The other thing really is to make sure that we didn't really have snowflakes in the environment or across the enterprise. So we wanted to make sure that we had a set of reasonable standards. Sometimes there are more than one standard, right? We might have two or three, but we wanted to make sure that all of those are enforced across of our enterprise. And when I say more than two or three, when I say that there are two or three, what I really mean is that we end up through the extensibility of the platform, which is something that's key as well, to let the business unit decide which standard that they prefer. So we lay out the groundwork, and then we allow them to opt in or opt out of certain things. The other important piece here is the ability to pivot. So if we decide as an enterprise or as a company that a particular technology is where we want to be headed to, we wanted to make sure that we as a platform team or engineering team have the ability to quickly pivot and kind of switch gears without really impacting the business or the apps themselves. And last but not least, whether they be through security compliance or AMI rehydrations, refreshes, or actual lifecycle changes to the different components, or even the infrastructure itself, we wanted to make a change, one, idempotent, but two, is simple to ingest from a business unit perspective. It just as another version of the platform to upgrade to. So this particular slide is really talking about the architecture and the overview. I'll start my way from the bottom up. As I just mentioned upon, the infrastructure is key. So obviously, the bare bones of the platform are things that are native services in AWS, whether they be EC2 instances, the AMIs that are referenced by the EC2 instances, auto-scaling groups, S3 buckets, etc. So that's the pure component. The layer on top obviously is EKS, so we use EKS to power the platform itself. And then the core features are things that we manage, we add on, and we kind of manage the lifecycle on behalf of the user, so they don't have to worry about these things. So things that come into mind, are security, obviously. So we don't really take any shortcuts around security, being in the financial and regulatory space. Things like access control, the cluster management lifecycle, tenancy or bootstrapping management, things even like logging and telemetry, et cetera, et cetera. And then finally, what we've learned over these past 2 years is, folks think of us as a platform of platforms, and what I mean by that is, because of Fidelity and the financial nature, we've had to tweak the platform, for example, to be extremely latent sensitive, and to be able to support applications that are latent sensitive. So those modifications or those tweaks kind of led us to having a trading platform. And then we've done similar things for the ML space, and we've done similar things for the API space. So these are all things that we consider as domain specific layers. So our goal is to really kind of abstract away some of the technical difficulties or technical challenges that a business unit might face, and provide them to them at the end of the day a trading platform or an API platform or an ML platform. So that's kind of the current state of affairs and kind of what we've grown into over the past 2 years. So the platform building blocks as well, we'll touch upon, Rajan, my colleague, will touch upon these here in a second. But really, this is the internal tools that we've built over the last 2 years to help enablement, to help the scalability of the platform. They're CLI tools, they're add-on management type tools. So these are things that we wanted to kind of communicate out to you guys as best practices as you kind of go through your journey.
Thank you, Neeraj. Hello, everyone. My name is Rajarajan Pudupati. I'm leading the engineering efforts behind this platform for Fidelity, where we are building this next-gen cloud-native platform for Fidelity. So, as Neeraj stated, we are building this platform on top of EKS, and what we are going to see today is the building blocks behind this platform. We're going to see a few things. We're going to talk about how users and CI/CD systems and other systems can discover the Kubernetes clusters they have access to using their enterprise credentials. We're going to talk about how the platform is versioned in Git and what sort of helps us with the deployment of the platform and maintenance of the platform. We'll also talk about how the tenancy management works in this platform. That refers to how the applications are onboarded, how the teams interact, things like that. We're also going to talk about how we use GitOps for cluster management. We're going to then talk about how what all strategies we follow to drive adoption for this platform. So the first one here is KConnect. KConnect is an open source project. KConnect is basically a connection manager CLI that lets you connect to different Kubernetes clusters across different providers. So typically in an organization, you'll have users, maybe like your application developers, and you have systems like CI/CD systems and security systems that might want to connect to a Kubernetes cluster for various reasons, right? And typically all they have is just an enterprise credential, enterprise identity. It could be Active Directory credential, a Google sign-in account or something like that. But for you to connect to an AKS cluster, you need to have something like kubeconfig, which basically has the API server endpoint, certificate, and then the credentials section, which is basically the user section. And the idea here is you just plug in your enterprise credentials into KConnect, and that will take care of figuring out what sort of access that particular identity has. And then it basically wires up the connection for that cluster. So for example, as you can see here, when you do KConnect use EKS and you give minus username and password, in this case, it's an Active Directory credential. If it was a Google sign-in account, you might have to tap yes into your mobile or something like that. So the moment you do this, it basically figures out what sort of clusters you have access to, and then it lists it out. It runs in an interactive mode, and you can actually point to which cluster you want to connect to. The moment you do that, it sets up the wiring. So the kubeconfig is completely abstracted away. So immediately after this command, you can start running your kubectl commands. You can also set up some meaningful aliases. For example, the very first time when you connect, if let's say very frequently you're connecting to a production cluster, you can actually say, hey, I want to connect to this cluster as like prod1, which means from next time onwards, you can simply say kconnect to prod1 and then say kubectl get pods. It automatically takes care of the connection. You can also do something like kconnect list, which is kconnect ls. So let's say in the last 2 days you have connected to 10 different clusters. KConnect list will basically show you all the connections, and then you can pick one of the clusters and then you can actually connect to it. So this is the development architecture. It's plugin based. So you have a couple of interfaces that the plugin needs to adhere to. You have like a provider interface and an identity interface. So the EKS plugin is already, that's the first plugin we wrote. It's already there. We are also adding more plugins, for example, for on-prem, Rancher, and AKS and stuff like that. We're constantly adding more providers. So feel free to check it out and contribute if you can. So the next one is CRON. CRON is Again, it's an open source project. It's a controller that runs within your cluster. It helps with add-on management, but it takes a slightly different approach when it comes to add-ons. For example, if you have EKS cluster and you run some add-ons on top of it, typically it takes certain time, maybe a few minutes, and then it comes into its desired state, which is okay. But for the most part, when you run a platform like this, you always have the situation where you want to have some set of add-ons that should come up first before the other add-ons can actually come up. So CRON, let me give you an example. For example, if you have a mutating webhook that injects a sidecar which takes care of some security related stuff, you want that to happen first before your other add-ons can be deployed. So CRON helps you with this, right? CRON takes this idea of layers. It's a Kubernetes extension. It's a custom resource. So CRON looks at add-ons packaged as layers. So for example, you can have like a security layer which contains some security related add-ons, and then you can have the EKS layer that depends on the security layer. So in that case, when you deploy those layers, which is as a Kubernetes manifest, when you apply them to the cluster, CRON will actually honor the dependency map. It will make sure that all the add-ons in the security layer comes up first, and the integration test for that security layer runs, and only if that is successful, it goes and applies the next set of layers. And CRON, again, it's built on top of other open source projects like Flux CD Toolkit. We use a couple of components from it, Source Controller and Helm Controller. As of today, Helm is supported. The add-on has to be packaged as a Helm chart. In the upcoming releases, we are planning to support other customization, other formats like customization, etc. So, yeah, if you look at this diagram, what you can see is you have this platform that runs in three verticals, right? You have this platform running on EKS, it has to run on on-prem and some other cloud provider. So if you look at it here, you have the security add-ons layer and common add-ons layer that runs across different cloud providers. But you have this AWS add-ons layer that is very specific to EKS. From a user standpoint, they're just looking at this custom platform that runs in any cloud, multi-cloud, right? But from a platform developer perspective, it's a nice way of basically composing this platform in terms of layers. It makes the management of the platform like very, very easy. The next one is tenancy management. So tenancy management refers to how the applications are onboarded to the cluster. Typically, just to take an example, if I'm an application lead, I have an application team of like 5 members, and I manage certain applications. So the way it works is like I go to the cluster admin, and then I request for something called NS group. So for making things easier, instead of having namespace as a first-class citizen, we sort of extended that and created a Kubernetes extension which is called NS group. So the idea here is, instead of giving a team access to a particular namespace, we give them to a namespace group, and that would allow them to add like more namespaces to it later. So me as an application team lead, I go to the cluster admin and I sort of submit a YAML file which represents this NS group. And if you look at that NS group, you typically see the namespaces, the name of the namespaces. It has the tenant details. That could be an AD group or an IAM role, and the tenancy management controller actually creates the AD group, for example, if it's not there, and adds the member to it. It takes care of those things. And the NS group also has a resource quota and a limit range section. So as a cluster admin, when somebody comes to me, based on various reasons, I can actually set the resource quota for them. And the tenancy manager controller takes care of it. So from the application team's perspective, they have to sort of adhere to it. They can add more resource quota objects, but it is within the context of what the cluster admin has set. So that's how it works. So if you look at this diagram, for example, at the top you have cluster admin who's actually creating the NS group, and on the left hand side you have these developers accessing the set of namespaces that they have access to. For example, if I'm part of NS group team 1, I can just access those set of namespaces. I cannot access a namespace that is part of NS group team 2. So that's how the boundary works. Most of our clusters are multi-tenant clusters, so this is like an important aspect for us. The next one is GitOps for cluster management. We heavily rely on GitOps model for managing the cluster lifecycle. So we have 2 important repos. The first one is the platform repo. So That is the repo from where the platform releases come out. So if I'm a platform developer, that's the repo where I go to add new features and stuff like that. The other side, you have a cluster repo. So the cluster has a one-to-one mapping with the Git repo. So if I have like 200 clusters, I'm looking at 200 Git repos. So if you open a cluster repo, typically you just see two things. One is a pointer to a platform version. You're saying that, hey, my cluster, production cluster 1, for example, points to platform version 2.0, which means anything and everything that pertains to that platform version gets applied to this cluster. The second thing I see in that cluster repo is a platform config options. So just to give you an example, let's say I'm a cluster admin and I want all the ingress definitions within this cluster to use a particular DNS name. That's where you give. So basically a set of options that is exposed by the platform, and the cluster admin provides that. Just these two things. So behind the scenes, you have a backing pipeline for this cluster repo. So me as a cluster admin, for example, if I want to upgrade a platform version, I go to the cluster repo, change the platform version, and the backing pipeline basically ensures that the desired state is met. So the backing pipeline typically runs, it looks at the cluster repo, it figures out, okay, this is the platform version, it goes to the platform repo, it figures out if it has to run any CloudFormation templates, then it runs EKS Scuttle, which takes care of EKS upgrades. For example, if you're going from 116 EKS cluster to 117 EKS cluster, EKS Scuttle helps with that. It helps with managing the node groups as well. And then finally, the backing pipeline will also apply these layers. So for this particular platform version, those add-ons are packaged as layers. So those layers are applied. And then CRON, which is already running inside the cluster, brings the platform to its desired state by deploying the layer. So once the upgrade, once the Kubernetes upgrade goes fine, the layers are successfully applied, that is when the backing pipeline actually exists. So when the backing pipeline exits successfully, then from a cluster admin standpoint, the cluster has successfully completed the platform upgrade, and then it's ready for use. I just wanted to have this slide here. It talks about some of the important platform add-ons. So just to give you an idea of what goes into a platform, right? So there are other add-ons outside this, but these are the major ones. So typically, for example, anything related to logging and telemetry, anything related to ingress, certificate management, policy management, secret injection. Secret injection, just to give some context, if let's say all your clusters are connected to something like Vault or AWS Secret Manager, we try to make things easier by injecting some sidecar that will actually do the initial handshake, get the token and stuff like that. So that's where the secret injection comes into picture. So all these are like completely abstracted away from the user. So from a user standpoint, these are the things that they don't have to worry about. And we also have RBAC management. Just to give you an idea, the platform defines certain roles. So it defines like a role called platform admin, an SRE role, and it basically defines the necessary permissions. So all those cluster role definitions, the necessary permissions, the bindings are managed as part of this add-on. The next one is driving adoption. This is an important slide. To be honest, my favorite slide in this deck. If you ask me, there is one thing that you want to take from this presentation, I would say this. Whatever we saw till now typically involves just the platform team for the most part. But when it comes to driving adoption across different application teams, it involves like both the parties, a certain level of commitment from both the parties. You have application teams on one hand, and the platform teams on the other hand. So to get that sort of commitment from the application teams as well to adopt your platform, you have to do a lot of different things. So you have to take that extra mile to do whatever you can to make things easy for them. The reason I say that is typically in an organization like Fidelity, where the rate of innovation is quite high, it's quite rapid. The application teams are quite busy with like a lot of business logic, right? So for them to move towards something new, or to move towards something new like a new platform, you have to make things really easy for them. So the way we do that is we establish certain channels, and we are highly committed to that channel. So one of the channel is something called a working group. So working group is where we have this representation from different application teams. Before I go there, the application team that you see on the right-hand side, they are actually from different business units. And within a company like Fidelity, each business unit is like an organization by itself with thousands and thousands of developers. It's quite big. So this working group has representation from a different mix of representation from the application teams. Usually it is some of the application developers, DevOps team members, security architect, application architect. It's quite a good mix. So they actually come to the working group, and from our side, we have the platform team members, SRE. We go to the working group, and this working group is something that happens once in 2 weeks. It's something like a 2-hour call, and that is where we basically create this feedback loop. For example, let's say as a platform developer, I come up with an idea I want to implement. I want to add a feature to the platform, which I believe it will be very useful for the application team. This working group is where that gets brainstormed. So we make it as a point to take an idea, take it in front of the working group, get the feedback, do a brainstorming session before we can actually implement. So sometimes you see that the idea gets killed right away there because it doesn't make sense. Sometimes it gets transformed into something totally different because the requirements are like that. And the reason for that is when you work with the application teams, in our case, they are our customers, there's always something that they know better that we don't know, right? So this working group model has been it has been going on for like 2 years now. It's quite effective. We do have other set of channels. We have tech forums, and for example, if there is a production cluster, you run into an issue, typically they raise an incident and it takes that flow. But if it's a development cluster where you're doing something and you run into a platform related issue, typically they go and create a forum request. It's similar to a Stack Overflow thing, where they raise the questions and someone from our side, either it's a platform team member or an SRE team member, answers those questions. Sometimes it will be a very simple basic Kubernetes question or something. Sometimes it will be like platform related. So initially, whether it is small or big, you have to help them out. Even if it's a simple Kubernetes question, you have to point them to the right documentation. And over a period of time, it gets better. So we are reaching a point where if it's a Kubernetes related question, they typically go to the BU side, DevOps team. And if it's a platform related thing, they come to the forums. The main idea here is through this channel, from an application team's perspective, they actually see what is coming next from the platform perspective, where is it headed, and what's going on today. And from the platform team's perspective, this channel is where you get the constructive feedback about the platform. You know where to move fast, where to slow down, and which direction to go, and stuff like that. So this is an extremely important thing for us. I just wanted to wrap up with lessons learned. First one is, as I said, this working group model is very effective, and we constantly try to find places where we can make things simple for the users. If we can abstract something away to eliminate some confusion, which is there in the teams, we always strive for that. The other point we have learned is about scaling. So scaling to 200 clusters shouldn't happen quickly. So what we noticed is you scale very slowly to begin with. It's okay if you run just 5 clusters for 6 months. It's totally okay. But you scale it, you take it to a point where you know for sure that from that point you can exponentially scale with no issues. Figuring out that point is extremely important. If you're actually working with this working group and creating this constant feedback loop, together as a team, you can go towards that point, and you know for sure that, hey, this is the point where I can actually scale to tens of clusters or hundreds of clusters without causing any problem to the stability. So taking it slow initially, figuring out the point at which your platform is stable, that's extremely important. The next one is do whatever you can to help with the culture change. There is a transition that happens. Usually it takes time, especially if you're in a large organization. Any culture change it's a difficult thing. It takes time. So just to give you an example, when we implemented the GitOps approach, we asked like different ops team members and application team members to commit certain things to Git directly, but we got a feedback and they wanted some sort of a UI in the front that will do some extra validation and then commit on their behalf. We did that. So it really worked out. It helps us take something to the first level, and over a period of time things will get better. Everyone will actually get comfortable with the process, so you might not need these things. So the point here is you do whatever it takes to make things happen. The last thing is so stability is extremely important, and at any point in time that takes precedence over like a new feature. For example, if you have an option where you are bringing in a new add-on which gives like a lot of new features, at the same time, if you're not sure about whether it'll be stable, we don't do it. At any point in time, if you are running a platform that runs across 200 clusters, we make it a point that when we roll out something, it has to be very stable. It shouldn't cause any confusion to the application teams. So we are very, very concerned about that. So at any point in time, stability is extremely important, and that stability directly translates towards the trust you gain from the application teams for your platform. So pick stability over anything at any point in time. So yeah, I think that's all I had. Thank you so much. I hope you enjoyed the session. Enjoy the rest of the sessions as well. Please do remember to fill out the survey that's coming up next. Thank you so much.